Everyone, this is internal first solution of our data science paper. I am Rishabh Gupta. Let's move on to the questions. We have a following scenario given where is a table represented a data trace training set of a data. It is a class level tuples from all electronics consumer database. I will show you the table. This is our table where we have reference ID, age, income, student, credit rating, and do they buy a computer or not. So we have this following scenario. The class level attribute by computer has two distinct values, yes or no. The class of people either buys computer or not, and we have two distinct classes, that is m is equal to 2. If class C1 correspond to yes, the class C2 corresponds to no. There are 9 tuples of class yes and 5 tuples of class no. We can see that in our table here. All the data can be collected from this table. We have this following questions. Find the splitting criteria for these tuples using computation of information gain of each attribute of decision. So for the first question, what we can do is calculate the entropy for the root node, as we have to also design the decision tree at the end. So we take a root node. So after calculating the entropy minus p1 log 2 base p2, log 2 base p1 minus p2 log base p2. So after calculating the information gain for each attribute, such as information gain of age, income, student, credit rating, income subsets are divided into three parts: low, medium, and high. Student subset, either the person buying a computer is a student or no, not. We can find it from here. Is he a student or not? So here are the values of yes and no's, and also the credit rating, which is also a very substantial factor here. So we choose the attribute with highest information gain as the splitting criteria. Information gain. After that, our second question is find the splitting criteria of these tuples using Gini index of each attribute. What Gini does is Gini tells us about the variation in our data. So to calculate Gini index, we use 1 minus summation of p square, and as we have m is equal to 2 here, so we will do 1 minus p1 square plus p2 square. And after calculating the Gini index for each attribute, same as we did for our information gain, we can choose the attribute with the lowest Gini index as the splitting criteria. Now here, after calculating both information gain and Gini index for each attribute, you can construct the decision tree by selecting the attribute with the highest information gain and the lowest Gini gain at each node. Compare the generated rules for both cases to analyze differences in the decision tree. And here we have decision trees. If the age is young and he is not a student, he does not need a computer. But if he is young and is also a student, he would buy a computer. Middle aged person will also buy a computer, and whether it comes to senior, we will see if its credit rating is excellent, then he can afford a computer. So this is our solution for internal first paper. Thank you for watching. Hello everyone, my name is Rishabh Gupta. This is solution video for our internal second test. The first question is write algorithm for decision tree induction. A decision tree is basically a machine learning algorithm. It uses nodes and branches. Branches are decisions, and the leaf nodes are result or outcome of the node, such as if we write if it is sunny outside, and branches state that yes or no. So if it is sunny, you will go out. If it's not sunny, you would rather stay at home avoiding the rain. So this is how a decision tree works. It is a top-down process that recursively splits the dataset based on feature that maximizes the information gain, such as if it is winter and then if it is sunny, then you would go out or not. You would make your decision based on such information. That's why it is written. It's a top-down process that recursively splits the dataset into features that maximizes the information gain or decrease in entropy. So the algorithm consists of these things. First of all, you input your data. such as features with target variable, and then you check the stopping criteria. If the stopping criteria are met, create a leaf node with the majority classes label and return it. So as I gave you the example of weather, you can understand it by that there is a root node, then there are branches, and then there are leaf nodes. If the branches conditions are met, then a leaf node is created, and then the process is repeated all over again. So after calculating the entropy of current data set, and the entropy also measures the impurity of disorder of a data set. Our next question is, what are selection measure for a attribute? So first we see the information gain of the attribute. So information gain is commonly used in decision tree algorithms. It measures the reduction in entropy of a data set when it is split based on a particular attribute. The second selection measure is gain ratio, and the third is Gini index. Gini index measures the impurity or disorder in a data, and the gain ratio is an extension of information gain that addresses the bias towards attributes with a large number of values. Our next topic is, what is mathematical expression for these information gain, Gini index, and the reduction in impurity. So information gain is P1 log base 2 minus P1 log base 2 P1 minus P2 log base 2, and then again P2. And for Gini index, we subtract 1 minus sum of all the squared possibilities, submission of those possibilities. And the reduction is impurity represent the amount by which impurity is reduced by splitting a data set based on a particular attribute. In the internal first solution, we have already seen the formula of Gini and the information gain. So our next questions are about what are overfitting and tree pruning. Overfitting is when a model learns training data too well, such as if you want to teach your model about the images of a cat, but instead of those only cat images, it is distinction doing distinction between animals, but it starts to capture the noise as well, such as trees, branches, and other cars and stuff. So we would not want our data set to be focused on those values. So if our data set has a lot of noise in it, it will result into overfitting of data. And for that, tree pruning comes into picture. Tree pruning is a basically technique that addresses the issue of overfitting by removing the parts of tree that do not provide significant predictive power. Means I would give the data set which has appropriate images of cats where there is not a lot of noise, and there are only main subjects such as cats or any other data I want my data set to learn. So thank you. This is the internal second solution of our data science paper.